fantastic. Nothing gives me more joy than when you buy everything from NVIDIA. I just want you guys to know that. But it gives me tremendous joy if you just buy something from NVIDIA. And so we have some great partners. L-Chip, Astera Labs, Marvell, and one of our great partners, MediaTek, are going to be partnering with us to work with ASIC or semi-custom customers, hyperscalers, who would like to build these things, or CPU vendors who would like to build these things, and they would be their semi-custom ASIC provider. We also have Fujitsu and Qualcomm who are building their CPUs with NVLink to integrate into our ecosystem. And Cadence and Synopsys, we've worked with them to transfer our IP to them so that they can work with all of you and make that IP available to all of your chips. So this ecosystem is incredible, but this just highlights the NVLink Fusion ecosystem. Once you work with them, you instantly get integrated into the entire larger NVIDIA ecosystem that makes it possible for you to scale up into these AI supercomputers. Now let me talk to you about some new product categories. As you know, I've shown you a couple of different computers. However, in order to serve the vast majority of the world, there are still some computers that are missing. And so I'm going to talk about them. But before I do that, I want to give you an update that in fact, this new computer we call DGX Spark is in full production. DGX Spark will be ready, will be available shortly, probably in a few weeks. We have tremendous partners working with us. Dell, HPI, ASUS, MSI, Gigabyte, Lenovo, incredible partners working with us. And this is the DGX Spark. This is actually a production unit. This is our version. However, our partners are building a whole bunch of different versions. This is designed for AI native developers. If you're a developer, you're a student, you're a researcher, and you don't want to keep opening up the cloud and getting it prepared, and then when you're done scrubbing it, okay? But you would just like to have your own, basically your own AI cloud sitting right next to you, and it's always on, always waiting for you. It allows you to do your prototyping, early development, and this is what's amazing. This is DGX Spark. It's 1 petaflops and 128 gigabytes. In 2016, when I delivered DGX1, this is just the bezel. I can't lift the whole computer. It's 300 pounds. This is DGX1. This is 1 petaflops and 128 gigabytes. Of course, this is 128 gigabytes of HBM memory, and this is 128 gigabytes of LPDDR5X. The performance is in fact quite similar. But what's most important is that the work that you could work on this is the same work you could do here. It's an incredible achievement over just the course of about 10 years. Okay, so this is DGX Spark for anybody who would like to have their own AI supercomputer. And it's, I'll let all of our partners price it for themselves, but one thing for sure, everybody can have one for Christmas. Okay, I've got another computer I want to show you. If that's not enough, and you would still like to have your own personal, thank you, Janine. This is Janine Paul, ladies and gentlemen. If that one isn't big enough for you, here's one. This is another desk side. This is also going to be available from Dell and HPI, ASUS, Gigabyte, MSI, Lenovo. It'll be available from Box, from Lambda, amazing workstation companies. And this is going to be your own personal DGX supercomputer. This computer is the most performance you can possibly get out of a wall socket. You could put this in your kitchen, but just barely. If you put this in your kitchen and then somebody runs the microwave, I think that's the limit. And so this is the limit. This is the limit of what you can get out of a wall outlet. And this is a DGX station. The programming model of this and the giant systems that I showed you are the same. That's the amazing thing. One architecture, and this has the ability, enough capacity and performance to run a 1 trillion parameter AI model. Remember, Llama is Llama 70B. A 1 trillion parameter model is going to run wonderfully on this machine. Okay, so that's the DGX station. So now let's talk about, remember these systems are, thank you Jimmy, these systems are AI natives. They're AI native computers. They're computers built for this new generation of software. It doesn't have to be x86 compatible. It doesn't have to run traditional IT software. It doesn't have to run hypervisors. It doesn't have to run it doesn't have to run Windows. These computers are designed for the modern AI native applications. Of course, these AI applications could be APIs that can be called upon by the traditional and the classical applications. But in order for us to bring AI into a new world, and this new world is enterprise IT, we have to go back to our roots, and we have to reinvent computing and bring AI into traditional enterprise computing. Now, enterprise computing, as we know, is really 3 layers. It's not just a computing layer. It's compute, storage, and networking. It's always compute, storage, and networking. And just as AI has changed everything, it stands to reason that AI must have changed compute, storage, and networking for enterprise IT as well. Well, that lower layer has to be completely reinvented, and we're in the process of doing that. I'm going to show you some new products that unlocks enterprise IT for us. It has to work with the traditional IT industry, and it has to add a new capability. And the new capability for enterprise is agentic AI. Basically, digital marketing campaign manager, a digital researcher, a digital software engineer, digital customer service, digital chip designer, digital supply chain manager, digital versions, AI versions of all of the work that we used to do. And as I mentioned earlier, agentic AI has the ability to reason, use tools, work with other AIs. So in a lot of ways, these are digital workers. They're digital employees. The world has a shortage of labor. We have a shortage of workers. By 2030, by about 30 to 50 million shortage. It's actually limiting the world's ability to grow. And so now we have these digital agents that can work with us. 100% of NVIDIA software engineers now have digital agents working with them so that they can help them, assist them in developing better code and more productively. And so in the future, you're going to have this layer, that's our vision. You're going to have a layer of agentic AIs, AI agents. And so what's going to happen to the world? What's going to happen to enterprise? Whereas we have HR for human workers, we're going to have IT becoming the HR of digital workers. And so we have to create the necessary tools for today's IT industry, today's IT workers, to be able to manage, improve, evaluate a whole family of AI agents that are working inside their company. And so that's the vision of what we want to build. But first, we have to reinvent computing. Remember what I said. Enterprise IT works on x86. It runs traditional software, such as hypervisors from VMware or IBM Red Hat or Nutanix. It runs a whole bunch of classical applications. And we need to have computers that do the same thing while it adds this new capability, called Agent AI. And so let's take a look at that. Okay, this is the brand new RTX Pro Enterprise and Omniverse server. This server can run everything. It has x86, of course. It can run all of the classical hypervisors. It runs Kubernetes in those hypervisors. So the way that your IT department wants to manage your network and how they want to manage your clusters and orchestrate workload works exactly the same way. It has the ability to even stream Citrix and what other virtual desktops to your PC. Everything that runs in the world today should run here. Omniverse runs on here perfectly. But in addition to that, this is the computer for enterprise AI agents. Those AI agents could be only text. Those AI agents could also be computer graphics. Little TJs, coming to you, little toy Jensens coming to see you, helping you do work. And so those AI agents could be either in text form, it could be in graphics form, it could be in video form. All of those workloads work on this system. No matter the modality, every single model that we know of in the world, every application that we know of should run on this. In fact, even Crisis works on here. Okay, so anybody who's a GeForce gamer, there's no GeForce gamer in the room. Okay, what connects these 8 GPUs, the new Blackwell RTX Pro 6000s, is this new motherboard. This new motherboard is actually a switched network. CX8 is a new category of chips. It's a switch first, networking chip second. It's also the most advanced networking chip in the world. This is now in volume production, CX8. In the CX8, you plug in the GPUs. The CX8s are in the back. PCI Express connected here. CX8 communicates between them. And the networking bandwidth is incredibly high at 800 gigabits per second. And this is the transceiver that plugs into here. So each one of these GPUs have their own networking interface. All of the GPUs are now communicating to all of the other GPUs on east-west traffic. Incredible performance. Now the surprising part is this, how incredible it is. So this is RTX Pro. This is the performance, and I showed you guys at GTC how to think about performance in the world of AI factories. The way to think about this is throughput. This is tokens per second, which is the y-axis. The more output your factory, the more tokens you produce. Okay, so throughput is measuring tokens per second. However, every AI model is not the same. And some AI models require much more reasoning. And so you need those AI models, you need the performance per user to be very high. So the tokens per second per user has to be high. And this is the problem with factories. Factories either like to have high throughput or low latency, but it doesn't like to have both. And so the challenge is how to create an operating system that allows us to have high throughput, the y-axis, while having very low latency, which is the y-axis, interactivity, tokens per second per user. And so this chart tells you something about the overall performance of the computer, of the overall computers of the factory. Look at all those different colors. It represents the different ways you have to configure all of our GPUs to achieve the performance. Sometimes you need pipeline parallelism, sometimes you want expert parallelism, sometimes you want a batch, sometimes you want to do speculative decoding, sometimes you don't. And so all of those different types of algorithms have to be applied separately and differently depending on the workload. And the Pareto, the outside area, the overall area of that curve represent the capability of your factory. Okay? And so notice something. Hopper is this is the most famous computer in the world, Hopper H100, the HGX, $225,000 Hopper is down there. And the Blackwell server you just saw, the enterprise server, is 1.7 times its performance. But this is amazing. This is Llama 70B. This is DeepSeek R1. DeepSeek R1 is 4 times. Now the reason for that, of course, the DeepSeek R1 has been optimized, and DeepSeek R1 is genuinely a gift to the world's AI industry. The amount of computer science breakthrough is really quite significant, and has really opened up a lot of great research for researchers in the United States and around the world. Everywhere I go, DeepSeek R1 has made a real impact in how people think about AI and how to think about inference and how to think about reasoning AIs. They've made a great contribution to the industry and to the world. And so this is DeepSeek R1. The performance is 4 times the state-of-the-art H100. That kind of puts it in perspective, okay? And so if you're building enterprise AI, we now have a great server for you. We now have a great system for you. It's a computer you can run anything on. It's a computer that has incredible performance, and whether it's x86 or AI, all of it runs. Okay, our RTX Pro server is in volume production across all of our partners in the industry. This is likely the largest go-to market of any system we have ever taken to market. So thank you very much.